Welcome to today's video. If you've ever wondered how the universe works, what physics really is, how it impacts our lives, or why it's so crucial for technology and the future, then this is the video for you. In the next few minutes, we're going to dive deep into the world of physics, but not just the complex theories and equations you might be imagining. We'll break it down in a way that's simple, engaging, and super relevant to your everyday life. We'll explore the fundamental principles of physics, from how motion and forces shape everything around us, to the fascinating mysteries of the quantum world and space exploration. Plus, we'll uncover how physics is behind some of the most important technologies we use today, like smartphones, AI, medicine, and even space missions. You'll see how the laws of nature not only explain the universe, but are actually driving innovations that are changing the world as we know it. But that's not all. We'll also take a special look at how physics and artificial intelligence are coming together to create mind-blowing advancements, from quantum computing to AI's role in space exploration. The future of these two fields is exciting, and the possibilities are endless. By the end of this video, you'll have a fresh perspective on physics and an understanding of how it's tied to everything from the gadgets in your pocket to the missions sending us to distant planets. So, if you're ready to understand how physics shapes the world around you, how it powers the technology we can't live without, and where it's taking us in the future, stick with us. Let's get started. Exploring the universe, how astronomers see faraway stars and planets. The universe is vast, and for centuries, astronomers have been working to unravel its mysteries. Thanks to advancements in technology and physics, scientists can now observe stars, planets, and galaxies billions of light years away. But how do they manage to see so far into the cosmos? Let's explore the tools, techniques, and the amazing physics that allow us to peer into the depths of space. The role of physics in space exploration. Physics is the backbone of space exploration. It governs everything from the motion of planets to the behavior of light. Astronomers use various branches of physics to understand how stars, galaxies, and even black holes behave. Without physics, we wouldn't have the tools necessary for space exploration, whether it's launching rockets, tracking the movement of planets, or analyzing the light from distant galaxies. Let's take a look at the fundamental methods astronomers use to study the universe. 1. Telescopes, the first big leap in space observation. The invention of the telescope was a game-changer for astronomers. Before this breakthrough, scientists could only rely on their eyes, which limited their view to the closest stars and planets. With a telescope, distant objects could be magnified, providing a much clearer picture of the universe. Early telescopes. In the early 1600s, Galileo Galilei was the first to use a telescope to observe the night sky. His discoveries, like the moons of Jupiter, proved that not everything revolved around the Earth. Reflecting telescopes. In the 17th century, Isaac Newton improved upon Galileo's design by creating the first reflecting telescope, which used mirrors instead of lenses. This innovation allowed astronomers to build much larger telescopes without distortion, space telescopes. While ground-based telescopes can capture incredible images, Earth's atmosphere interferes with observations. To overcome this, astronomers launched the Hubble Space Telescope into orbit in 1990. By operating above the atmosphere, it captures much clearer images of distant stars and galaxies. 2. Observing light from distant objects. To study the universe, astronomers primarily rely on light. However, not all light is visible to the naked eye. Different types of radiation, such as infrared, radio waves, and X-rays, reveal different information about distant objects. Visible light. Most of what we observe with telescopes is optical light, the same light our eyes can see. However, visible light only tells us part of the story. Infrared light. Some objects, such as dust clouds or newly formed stars, emit a significant amount of infrared radiation. Telescopes like the James Webb Space Telescope allow astronomers to see through these dust clouds and study objects that are invisible in visible light. Radio waves. Some objects, like pulsars and black holes, emit radio waves instead of visible light. To detect these, astronomers use radio telescopes like the Arecibo Observatory, until it collapsed in 2020, and the Very Large Array, VLA. X-rays and gamma rays, the most extreme processes in space, like black holes and supernovae, release high-energy X-rays and gamma rays. Telescopes like the Chandra X-ray Observatory can detect these signals to provide insight into some of the most energetic phenomena in the universe. 3. Spectroscopy, breaking down light. One of the most powerful techniques in astronomy is spectroscopy. By splitting light into its components, like a prism splits sunlight into a rainbow, astronomers can gain vital information about distant objects. Redshift and blueshift. The light emitted by stars or galaxies often shifts depending on their motion relative to us. When an object is moving away from us, the light stretches into longer wavelengths, a phenomenon called redshift. If it's moving toward us, the light compresses into shorter wavelengths, known as blueshift. Chemical composition. Each element or molecule absorbs light at specific wavelengths. By analyzing the spectrum of light, astronomers can determine the chemical makeup of distant stars and planets, even if they are millions of light years away. 4. Gravitational lensing, using gravity to see the unseeable. One of the most fascinating techniques used in astronomy is gravitational lensing. This occurs when the gravity of a massive object, such as a galaxy or black hole, bends light from objects behind it. This bending works like a magnifying glass, allowing astronomers to observe distant objects that would otherwise be too faint to detect. Gravitational lensing has also been crucial in helping scientists learn about dark matter, which doesn't emit light but exerts a gravitational pull. 5. Interferometry, combining telescopes for higher resolution. Sometimes, even the most powerful telescopes don't provide enough detail to study faraway objects. That's where interferometry comes in. This technique involves combining the signals from multiple telescopes, effectively creating a much larger instrument with better resolution. A prime example of interferometry in action is the Event Horizon Telescope, EHT, which captured the first ever image of a black hole in 2019. By linking radio telescopes around the world, the EHT created an Earth-sized telescope capable of imaging the black hole's event horizon. 6. Space-based observatories, bypassing Earth's atmosphere. To get clearer images, space-based telescopes are essential. The James Webb Space Telescope is one of the most advanced observatories launched into space. It helps astronomers look deeper into the universe and study phenomena like exoplanets, the early universe, and the formation of galaxies. By operating above Earth's atmosphere, space telescopes like Hubble and Webb avoid the distortions caused by air turbulence and light pollution, providing us with sharper, more detailed images of the cosmos. The future of space observation, AI, and quantum physics. Looking ahead, the future of space exploration is intertwined with the fields of artificial intelligence, AI, and quantum physics. New advancements are expected to further enhance how we observe and understand the universe. AI is already helping astronomers sift through vast amounts of data from space telescopes and simulations. With its ability to spot patterns and identify unknown phenomena, AI will continue to play a critical role in astrophysics and space exploration. Quantum computing holds the potential to revolutionize space exploration by simulating the universe in ways we can't yet imagine. With the processing power of quantum computers, scientists may be able to model the behavior of galaxies, black holes, and even the origins of the universe. Conclusion: peering deeper into the cosmos. Thanks to advancements in technology, physics, and data analysis, astronomers can now observe distant stars, galaxies, and black holes with remarkable detail. From telescopes to advanced AI-driven analysis, these tools have opened up a whole new understanding of the universe. The future of space exploration is bright. With upcoming missions, next-generation telescopes, and quantum computing, we'll continue to push the boundaries of what we know about the cosmos. Who knows, maybe the answers to the deepest mysteries of the universe are just around the corner. So, as we've explored today, physics isn't just something you study in a classroom or read about in textbooks. It's the very foundation of everything around us. From the smallest particles that make up our world, to the vast cosmos beyond, the laws of physics govern how everything works. We've seen how mechanics, thermodynamics, and quantum mechanics explain everything from how we drive to how smartphones function, and even how artificial intelligence and space exploration are evolving. Physics is behind the incredible technologies we rely on every day, from medical innovations like MRIs to futuristic systems like quantum computing, all of which are shaping the future of AI and space travel. The beauty of physics lies in its ability to connect seemingly unrelated things, whether it's the theory behind rocket science or the physics of light, helping astronomers peer billions of light years into the past. And as we move forward, the marriage of physics with fields like AI promises to unlock even more potential for solving the complex challenges of the future. So the next time you look at your phone, hop into a car, or hear about the latest space mission, you'll know physics is behind it all. It's not just a branch of science, it's a way to understand the world and the universe on a deeper level. And with the rapid advancements we're making in technology, physics is going to keep driving innovation for generations to come. Thank you for joining me on this journey through the world of physics. If you found this video interesting and want to dive deeper into how science is shaping our future, make sure to like, subscribe, and hit the bell for more exciting content. See you next time.